So this is M49, which is stratospheric ozone depletion. So in this chapter, or in this section, it goes over the ozone and depletion from CFCs, why the stratospheric ozone is important, but why the tropospheric is really bad. So the tropospheric is where we live in the troposphere, and that would be our typical smog, whereas in the stratosphere, it protects us from UVB and UVC radiation, which is really damaging to our cells, causes skin cancer, and a variety of really negative things. So down here at the bottom, describe how UVA, UVB, and UVC affect formation of oxygen, or ozone, I mean. So ozone is O3. The oxygen we breathe is O2. So how do those things affect the formation of O3? And then what are CFCs and how do they affect ozone? So CFCs were something that were banned in the late 90s, and they deemed that they were extremely bad, breaking down the ozone. They used to be really common. Refrigerants had CFCs. Hairspray cans, I remember when back in the 80s with hairspray, they contained it. And so it was a really big deal to get hairspray that didn't have CFCs. And so so that was my high school years, was going through the CFC ban. But what are they, and how do they affect ozone? And then how does chlorine break down ozone? So chlorofluorocarbons are what CFCs are. So particularly the chlorine in the chlorofluorocarbon is what hurt the ozone. And so kind of know this equation that's listed here and how chlorine breaks it down. Why is chlorine considered a catalyst? So it does describe what a catalyst is if you don't remember from biology. But how is that considered? Why is chlorine a catalyst in that reaction? And then moving over to 559, why is the hole in the southern polar region seasonal? So over Antarctica, it's seasonal. And so we noticed over time that this ozone layer was growing thinner and thinner, and then there was an actual hole in it. So why, one, is it over the polar regions, and then why is it seasonal? So read about that. And then how does UVB affect living tissue, and UVC? So UVA is short wavelength. It doesn't generally, it does affect us, but not nearly as much as UVB and UVC, which is the majority of what is blocked by the ozone. So how do those things affect living tissue? What does it do to our skin or to plants or anything that's involved in it or in it? And then down at the bottom, there was this Montreal Protocol, and what did that do? So what did it accomplish in regards to the ozone layer? And that concludes M49.